Welcome back to my YouTube channel, and we are here now to discuss summary chapter 7. Okay, let's start. Chapter 7 is entitled IP addressing. Addressing is a critical function of network layer protocols. Addressing enables data communication between hosts, regardless of whether the hosts are on the same network or on different network. So, today, more than 99% of our world remain unconnected. Tomorrow, we connect everything. IP, IPv4 addresses. Binary is a numbering system that consists of numbers 0 and 1 called bits. In contrast, the decimal numbering system consists of 10 digits consisting of the number 0 to 9. Binary is important for us to understand because host, server, and network devices are binary addressing. IPv4 addresses expressed in binary. So LAN network addresses here and LAN B. So positional notation. So radix. The first row identifies the number based on radix. The decimal notation system is based on 10. Therefore, the radix is 10. Then the position in number. Second, the number also represents the exponential value that will be used to calculate the positional value. Then calculate the third row calculates the position value by taking the radix and raising it by the exponential value of its position. And then the positional value is the final answer or the number base or radix. Learning to convert binary to decimal requires an understanding of positional notation. Positional notation means that a digit represents decimal value depending on the position the digit occupies in the sequence of numbers. Then binary to decimal. So to calculate to convert a binary IPv4 address to its dotted decimal equivalent, divide the IPv4 address into 4 digit or 4 bit octets. Next, apply the binary position value to the first octet binary number and calculate accordingly. So decimal to binary conversion. So it is also necessary to understand how to convert a dotted decimal IPv4 address to binary. A useful tool is to binary positional value table. The following illustrate how to see table. Convert decimal to binary. So this is the formula. Is decimal and greater than or equal to 128? If if yes, add 1. Then the n is 128, and if no, add zeros to cancel. And then 60 n is greater than or equal 64. If yes, 1, 2. And then if no, 0 to cancel. Then also here, here, here. Decimal binary conversion example. So like this, the number is 192. 192 is greater than 128. So therefore 192 is 192 is greater than or equal 128. Yes, so add 1 to 192 minus 128 equals 64. So the 64 is greater than or equal 1 and add 1 again. So that's it. Then so it's the activity here. Binary game. Network and host portion. Understanding binary notation is important when determining if two hosts are in the same network. Recall that an IPv4 address is an hierarchical address that is made up of network portion and a host portion. When determining the network portion versus the host portion, it is necessary to look at 32-bit string. So the host portion is 10. So network portion here and IPv4 address. Then the host portion is 10. Then the binary is 01 ay 00001010. So total of 10. Because 1, 2, 4, 8. Just 8 plus 2 is equals to 10. Then the subnet mask. Subnet mask is 255.255.255.0. Then IPv4 unique address of the host and subnet used to identify the network host. Default gateway identified the local so logical and operation. So 1 and 1 is equals to 1 and 0 and 1 equals to 0, then 0 0 is 0, 1 and 0 is equal to 0. Then logical and is one of three basic binary operation used in digital logic. The other two are OR and NOT, while all three are used in data network and AND is used determining the network address. Therefore, our discussion logically AND operation. So the prefix length expressing network addresses and host addresses with the dotted decimal subnet mask address can become cumbersome. Fortunately, there is an alternate shorthand method of identifying a subnet mask called prefix length. So to get the prefix length, you can count how many 1, 2, 3, 4, 5, 6, 7. You can count how many 1 in 32-bit address to find prefix length. The need for IPv6. IPv6 is designed to be successor to IPv4. IPv6 has large 128-bit address space. Then the IPv6 address representation are IPv6 addresses are 128 bits in length and written as a String of hexadecimal values. Every 4 bits of represented by a single hexadecimal digit for a total of 32 hexadecimal value as shown as figure 1. Here, hex that hexadecimal numbering. So, if the number is 10, write A, 11, B, C, D, F, E, F. Then ICMP B4 and ICMP B6. Although IP is only the best effort protocol, the TCP IP suite does provide for messages to be sent in the event of certain errors. These messages are sent using the services of ICMP. Then then standing binary notation is important when determining if two hosts are in the same network. Bits within the network portion, the IP address must be identical for all devices and reside in the same network. The subnet mask or prefix is used to determine the network portion of an IP address. IP addresses can be assigned either statically or dynamically. So, done for chapter summary, chapter 7 summary. Thank you for watching.